Hi, welcome to the presentation on sensitivity analysis in the Monte Carlo simulation. My name is Barnabas Chinaro and I'm a second year computer engineering student from UKZN. For our agenda today, we're going to have an overview on Simulink design optimization, then we're going to focus on sensitivity analysis, and then I have two demos that I'm going to present to show you this toolbox. One is a rectifier amplifier circuit model, and the second one is a mass reflex model. So, what is Simulink design optimization? Basically, it is a toolbox. It is a toolbox that provides functions, interactive tools, and blocks for analyzing and tuning model parameters. It is used in parameter estimation, response optimization, and in sensitivity analysis, amongst other things. So, in parameter estimation, one can be able to improve accuracy through estimating the model parameters from the test data. In response optimization, one is able to tune model parameters to meet the requirement. And in sensitivity analysis, which is going to be our main focus for this presentation, one uses techniques like Monte Carlo simulation and design of experiments, which enables one to explore the design space and calculate parameter influence on the model output. So, what is sensitivity analysis? It is the study of how variations in the parameters affect the output behavior for a model. Here in this diagram, we have one of the cool features that this toolbox comes with, which is the tornado plot. The tornado plot is simply a way that you can use to statistically analyze the parameter influences. So in this case, we can see that we have 4 parameters that we're analyzing for our output. So the length of these bars is the one which shows the extent to which the parameter affects the output of our model. So why should we perform this sensitivity analysis? Well, it can increase reliability and robustness, and also we're able to reduce costs and also improve on performance. So how do we perform this sensitivity analysis? The cool thing about this, we only need 4 steps, just 4 steps to perform this. Well, the first step is we select our parameters of interest. These are the parameters which we think are going to be affecting our model output. Then next step, we create a sample set. This is where the Monte Carlo technique is implemented in generating random variables to create our sample set. And this sample set is going to be our input for our analysis of our output. So the next step, we then evaluate against the model requirements. So in one of our models, we're going to require to see the parameters which affect the max voltage, the parameters which affect the rise time more than the others. Then lastly, we can graphically or statistically analyze the data. Like I said earlier on, I have 2 models that I'm going to represent to you. And the first one is a rectifier amplifier circuit model. So here we have our signal source as an AC, which is then translated into a DC source by this full bridge rectifier, and then it is amplified by our operational amplifier to give us our output. And our second model, I'm just going to let the animation tell you what's happening. This is a mass reflex model that we have. It's simply representing the phenomena that we have on the left hand side. Now, back to our model. We're going to switch over to Simulink to perform our sensitivity analysis on this model. We want to discover which parameters, which inputs rather, affect our voltage output that we. Now that we've opened our model, we can perform our sensitivity analysis. So for us to do this, we go to the Analysis tab, then we click on Sensitivity Analysis. After this, it shows us a window. Click on this tab, then we create a new parameter set. So we pick out the parameters that we think are going to affect our output. So in this case, I'll pick out CR, R1 and R2. TS is just time, which is actually dependent on the other parameters, so it won't affect our output. Then we click OK. Now we have our parameter set. Next step, we have to generate our sample set, the values that are going to use as inputs for evaluation. So we go to this tab, generate values, then we click on generate random value. Okay, now this also gives us another window where we can specify our samples and our distribution for our individual parameters. So for our number of samples, then the sampling method is random, and our distributions, currently they are all set to uniform, but then I want to change the C and the R for them to be normal. And by normal distribution, we simply mean that the probability of the value being there lies around a certain mean. And then by uniform, we mean that there's an equal probability that the value is actually there. So I want to change my deviation to 5 nanometers, and for my resistance to 300. Double click. Another cool feature that we have from this is that if we know that there are parameters which are correlated, we can simply click on them. Like, let's say C and R are related. We can check those checkboxes there, and then we specify the extent to which they are correlated by clicking on this tab. Then you can specify if it's 0.96 or something like that, then it can go to our favor. But in this case, there is no correlation. We don't have that information. Now we click OK. Now we have generated our sample set, and we can check if they are random by generating a scatter plot from that sample set. So for us to do that, we can go to sample set and right click, then we simply click plot. Now we've generated our plot, and these histograms show the probability, and the scatter plots show how much apart they are, like the values that we have, how set apart they are. This simply shows that they are all random. Now the next step that we need to specify our requirements for the evaluation. So like I stated earlier on, we are analyzing the max voltage and the rise time. So we go to new requirement. So for our max voltage, we are going to use the signal property. The property wants a signal maximum, and the type we want it to minimize that property. Now we have to select our signal, and we select by adding the signal to this list. So we click on this add button. Now for us to import the signal from the model, we have to go back to the model and click on that specific signal that we need to import. So we click on this. You can see that there is a circle. The arrow turns into a circle when you over the arrow. So we just simply click on that, then we return. Now we see that it has been imported. Now we just simply have to transfer it here to add it to our list. Then we click OK. Now we have our signal property, and we close. Another cool feature that we have is that we can actually rename these requirements so that we can not get lost eventually, like if the requirements are so many. So we specify this one to be max volt. Now our next requirement is the rise time, and the rise time in this case we're going to use custom requirement. And by custom requirement, I mean that it's a function that you have already defined, like it's user defined. So the type, again, we minimize the function, and the function itself, in this tab I specify the name of the function that I would have written. So in this case, my function name is rise time filter. Then for us to confirm that is there, we can click open. Right, now turn over to the MATLAB view, to the command view. Now we see that this is the function that I defined. It uses the step info function, which I'm not going to focus on right now, but then it's simply part of the control systems. Okay, now I go back to my model, to my analysis tab. Then I have to select the signal again. So as you can see, it is already here, but then you just need to check it. Okay, now we're done with our requirements. I can again rename that requirement to rise time. Okay, now that I have my requirements, the only next step I need is to evaluate the model. So for me to do that, I come to this button here and I click evaluate model. So now it's evaluating the model. You can see that it's actually processing something in the background for our analysis. So what is it doing now? Now it's simply checking the sample set against our outputs that we have defined, the requirements that we have defined here. So these red dots, they simply show the current sample set that's been plotted, the current inputs that's been plotted, like this one and there. Okay, this process takes a bit of time. Now it's done processing the evaluation, and this is our output. Now we can see that from our scatter plot, we have C, R, R1, and R2. And from these scatter plots, we can see clearly, especially from C, that the relationship between rise time and C is directly proportional. And in these other plots, we can't really distinguish a relationship. Now looking at the max voltage, you can see that C and R, they don't really have a relationship. But then in R1, is the R1 increases the voltage, the max voltage decreases, and in R2 it's vice versa. This we can also see more clearly by right clicking on one of the scatter plots. Then we activate the overlay linear feed by clicking on it. Now we see these lines. These are the lines of best fit. Now we can clearly see that all these values lie around that line, and these ones lie around that line, and so do these ones. Another cool feature, like I had said before, is that we can graphically or statistically analyze the data. So now we're going to take this data and we're going to analyze it statistically. So what we can do, we'll go to the statistic tab, and then we specify the method. So I'm just going to use all of them: the partial correlation, the standardized regression, and the correlation. And then I'll click on compute statistics. Now what this is going to do is going to give us a tornado plot. The tornado plot that I defined earlier on, which is actually a more colorful way, or rather it's more precise. It clearly defines the extent to which the parameters affect the output. Now we see R1 and R2 affect the max voltage to a great extent as compared to the rest of the parameters, and in rise time, the C affects the rise time the most compared to R2, R1, and R, which is what we saw in our scatter plot. Now we have managed to explore our design space. Now we'll switch over from our rectifier amplifier circuit. We can conclude that if maintaining a steady max voltage is more important, we can simply use an R1 resistance that is low and a high R2 resistance. And if rise time needs to be less, a smaller capacitance can be used, and vice versa for the rise time to be more. Now we look at our second model. I'm going to switch over to Simulink. Okay, in this model, we want to use sensitivity analysis to improve parameter estimation for matching the test data. So what we do, we click this block here, which is some preloaded data. What we have here, we have the test data that we're trying to match. So we want our model to match this particular data that we have. So currently, if we click plot model response, it will plot the current response that we have from just the initial values that we have from our model. And we can clearly see that yes, it does follow the trend, but then the values that we have are so off. So we want to closely match the test data that we have. So how are we going to do this? We could simply click on estimate, but the only problem about this is that it's going to take so many iterations for it to complete. So we're going to use sensitivity analysis so that we can be able to see which parameters affect the output the most, so that we can be able to just pick out these particular parameters to use for our estimation, and not to use the other ones that really don't affect the parameters, the output. So what do we do? We go to sensitivity analysis, and then we say open sensitivity analysis. So here we click on the experiment that we're going to use, which is our reflex response model. Now, since we don't know which parameters we want to analyze, we're going to export all of them for the analysis. So we click on there. Now this is going to open the sensitivity analysis tab that we actually used earlier on. And now we can see that our parameter set is already defined and our reflex response is already defined. So what we need our sample set. So we're just going to perform our sample set like we did before. So we create random values. The number of samples that I'm going to use, I'm just going to use 50 again, but then the rest of the information I'm just going to keep it as it is. Okay, now we have all 50 samples that we need, and the next step that we need to do, since we already have our requirements, we just need to evaluate the model. This is our final plot. What I can say is that the y-axis here is simply representing the magnitude of error, and by it having these high values here, it simply shows that the error is very high. So how is this going to affect us? It's going to affect us when we're now performing our statistical analysis. So for us to curb that, we'll use our ranked data type, unlike the linear one that we used for our previous model. Now we have to identify the good initial point. So how do we do this? We can right click on this and use another cool feature that sensitivity analysis has, which is enabling brushing or data selection. So we use that to select the data points that we want. So we can click on it, drag. Now we have a problem. We want to select just one point, but then using this method would make it difficult for us to select that one point. So what we can do, an alternative, we can go to the table view, and then we can sort the table in terms of reflex response. Now we just need one point, and the good initial point would be that point with the least uncertainty, or least error rather. Then we right click and extract the parameter values, and we see that is also amongst the results here. Now what do we do next? we need to find the most influential parameters. So we go to the Statistics tab, and then we pick the methods that we want, but then we use ranked data instead of linear. Then we compute the statistics. So from these statistics, we can see that K, B, J, and alpha affect the output more than tau, beta, and TD. So now that we know the parameters which affect the most, and also we now have our good initial point, we now need to perform our parameter estimation. So we'll go to the sensitivity analysis tab, then we'll go to optimize, then we create a parameter estimation session. First of all, we have to select our good initial point, which is our initial guess, which is the point that we extracted, and also have to specify the experiments to import. Then we click OK. This brings us back to our parameter estimation. So now we need to select the parameters we're going to use for our parameter estimation. Here we're going to use beta, J, K, and alpha. Then we'll untick the rest, as they are going to simply slow down our progress, but they not really make much effect. Now after selecting our parameters, we simply click estimate, and after estimation we can see that the graphs are now more alike, and this was only done after 1, 2, 3, 4, 5, 6 iterations. Now from our muscle reflex model, we managed to tune it to meet the requirements and to fit the model to the test data, and also managed to reduce the estimating time by using the more influential parameters. We can see this by this analysis here. This is without the sensitivity analysis. It had to go through 31 iterations, and with sensitivity analysis it was only 5, 0 base. So we can see that sensitivity analysis is a really strong tool that we have. So in summary, from the models we were able to explore and analyze the design space, and we managed to determine the most influential parameters, and we managed to reduce the estimation time for modeling, and to tune and fit a model to its test data. So how can Optimum Solution help you? Our Optimum Solution is a sole distributor of all the networks tools in Southern Africa, and we offer training on how to use these products that we offer. And not only that, we also offer consulting services on the products that we have, so that we can help accelerate your development. So for each of the courses that we do, there is a learning part. So like for this presentation that I had, I was following the control and algorithm design learning part. Firstly, what you need to have is a fundamental, the MATLAB for Simulink users. Then you need to go over Simulink for system and algorithm modeling, and also control system design with MATLAB and Simulink, so that you can be able to correctly design, simulate, and test a variety of controllers. Moreover, the next steps that you take, you can go to the networks website solution pages, and you can go under control systems. There you can see all the tools that I used for this presentation. You can also download a trial. If you are a more hands-on person and you want to discover more about this, you can try out the trial. And good thing about us, we have a strong team of scientists and engineers that can help you improve in all the aspects of networks that you may require. So we offer that much support, and you can also check out our competency on our Optimum website.